So in this video I'm going to expand a bit more on covalent bonding. So I'm just going to give you some examples where you would see double bonds, triple bonds, and we're going to look at molecules that are non-octet molecules. In other words, they don't adhere to the octet rule where you would have 8 electrons in the outer shell. So we'll start off with double bonds. So I'm going to use an oxygen molecule as an example where you've got 2 oxygen atoms involved. So oxygen is in group 6, so it has 6 electrons in its outer shell. So to be stable, oxygen wants 8 electrons in its outer shell, so each oxygen atom needs 2 electrons. So rather than more oxygen atoms coming in, each oxygen atom actually shares 2 of their electrons. So to share, we overlap those outer shells and each oxygen atom is sharing 2 of their electrons. So where our atoms overlap, we've got 2 crosses from one of the oxygen atoms and we've got 2 of the red dots from the other oxygen atom. So a covalent bond is just a shared pair of electrons. Now in this case we've got 2 shared pairs of electrons, so we form that double bond. Okay, so we now have an example of a triple bond. So we're going to look at a nitrogen molecule. So 2 nitrogen atoms in a nitrogen molecule, as you can see up at the top. So nitrogen is in group 5, so it's got 5 electrons in its outer shell. So to be stable and get 8 electrons there, we need to share 3 of our electrons. So again, rather than bring in lots of different nitrogen atoms, get them involved, we're going to share 3 electrons each. So we overlap the outer shells of our electrons, and where those atoms overlap, we've got 3 electrons from one of the nitrogen atoms, the red dots, and 3 electrons from the other nitrogen atom, the blue crosses. So we've got 3 pairs of shared electrons. So we have 3 bonds, so a triple bond. So our final set of examples that we're going to look at are molecules that are non-octet molecules. So what I mean by that is that they don't follow the octet rule. Every single one of the molecules we've been looking at so far have had 8 electrons in their outer shell. So they've wanted to be stable by getting a full outer shell of 8 electrons. The examples I'm going to show you on here do not follow that rule. So the example I have in front of you, BF3. So we've got a boron atom in the middle and 3 fluorine atoms around the side. So fluorine is in group 7, so it's got 7 electrons in their outer shell, which are represented by those red dots. So each fluorine atom's got 7 of those red dots. Boron is in group 3, so it has 3 electrons in its outer shell. So as you can see with the blue crosses representing the boron electrons. So each of those electrons is shared with a fluorine atom. So you can see that the fluorine atoms now have 8 electrons in their outer shell, but boron only has 6 electrons in the outer shell. Now this may get you thinking that actually there's not got a full outer shell, but this molecule is actually stable like this, and it's because boron is actually using all the electrons to form bonds. So it's only got 3 electrons in its outer shell, so it can only form 3 bonds. So it is actually quite stable with 6 electrons in its outer shell. So our last example is something else that doesn't follow the octet rule. So this is SF6. So sulfur is in group 6, so it's got 6 electrons in its outer shell, represented by the blue crosses. And we've got 6 fluorine atoms, which are in group 7, so they've got 7 electrons in their outer shell. If you look at each fluorine atom, so it's sharing with one of the sulfur's electrons, so fluorine now has a full outer shell. But you actually look now at sulfur, each of those electrons is sharing with a fluorine electron, so they actually have 2 electrons being shared here, 2 here, 2 here, 2 here, 2 here. So we've now got 2, 4, 6, 8, 10, 12 electrons in the outer shell. So that's actually bigger than 8, obviously. So usually molecules need 8 electrons in their outer shell to be stable, but this sulfur has 12 electrons in its outer shell. And this is known as expanding the octet. So rather than just 8 electrons, we've actually got more, we've got 12 electrons in the outer shell. So why can sulfur do this? So if you actually look at the periodic table and where sulfur sits, sulfur is in the 3rd row of the periodic table, which is known as period 3. So when you get down to period 3, the electrons the outer electrons, are in the 3rd shell. So you were probably told at GCSE that in the 2nd shell you can fit 2 electrons, in the 1st shell you can fit 2 electrons, in the 2nd shell you can fit 8, and in the 3rd shell you can also fit 8. So this is true for probably the elements that you've kind of looked at and it fit in with everything, but now actually the 3rd shell in there you can actually fit 18 electrons. So sulfur can actually fit those 12 electrons around its outer shell, so this molecule will be stable.